Y ahora sí estamos llegando al National Weather Service. Así que voy para allá adentro.
Weather Service, and we certainly appreciate you sharing part of your Saturday with us. And it's raining a little bit outside, but as I said earlier, that's kind of an exciting thing for us in terms of just weather. But my name is David Sharp, and I'm a meteorologist here. And a meteorologist is just a fancy science talk for weather person, right? You know, and so I'm a meteorologist, but I'm also a science and operations officer. So for the folks a little bit more mature in the audience, it's that Spock thing, you know, science officer. But what's real neat about that is that I get to talk with folks at the universities and the research labs and try to help transition the latest science and the latest technology out onto the floor for our meteorologists here, so that in turn you all get to reap the rewards and benefits of that. So kind of excited and happy about that. But here, we are your local National Weather Service office located here in Melbourne, Florida. And we want to talk a little bit about who we are. And, well, we're the government, for one. but two, we're oddly part of the Department of Commerce. Okay, we're part of the Department of Commerce. Now, that'll make a little bit more sense as you go along. You think about what weather affects and how it affects a lot of things, you know, agriculture, transportation, commerce. And so we're in the Department of Commerce. But when you get to this level here, the NOAA level, National Oceanic and Atmospheric Administration level, you know, the seagull people, then we start getting a little bit of identity. Oh, you're the seagull people. You're NOAA. You're with NOAA. And NOAA has an oceanic component and an atmospheric component. And so if you're the Weather Service, you're part of the atmospheric component. So that's kind of how you get from the Department of Commerce all the way down to the National Weather Service. But that's who we are. So our job is to forecast and warn for weather. But when it comes to mission, you know, every entity in the government and, well, any business has a mission. But for us, we have what they call a noble mission, okay? And that's one of the reasons why folks are excited. And we're all weather geeks, you know, but beyond that, to get up and go to work in the morning and to do some of the things that we have to do, and at the times of day that we're asked to do them, is because of the mission. And it's what we call a noble mission, and not many have this, and we're very privileged to have it. But our job is to protect lives. Now, we also have the purview to help protect property, and our mission is expanding economic interest. You can understand that these days, right? And then also the environment as well. But largely, it's to protect lives. So your safety, my family's safety, is at the forefront of our minds every day. So when we produce forecasts and warnings, it's your safety and the safety of all East Central Floridians that we have at heart. Now, here we are. We are here. We are this red area. So notice that we're not just taking care of Melbourne or Palm Bay. We're not just taking care of Brevard County either. We're taking care of all of East Central Florida. So if you want to jump in your car and drive all the way to Leesburg, well, all that whole trip that you just made, that's still what we call our community. You drive all the way down to Lake Okeechobee, that's still our backyard. If you Daytona Beach, all the fun that's happening at Disneyland and Universal Studios, all under our umbrella. The Nation Space Program, all under our umbrella. If you go off from Flagler Beach, 60 miles off the coast, and travel all the way down to 60 miles off the coast of Jupiter Inlet, still all part of our community. So a fairly large community, but when you start comparing it to the rest of the country, you realize it takes 122 weather forecast offices, WFOs, just like us, to be able to cover every single acre of ground across the entire country, to include Alaska, to include Hawaii, and even interests such as San Juan, Guam, all of these places that have American interest in it as well. So why? Because weather can happen anywhere at any time.
It's like the Albuquerque weather forecast group has the short end of the stick there.
yeah, it's a little tough out there.
Serious area.
Well, you said it's about as far as I can see. Yeah, and then some.
Yeah, exactly.
But you know, the diversity. Sometimes weather can be very diverse. We actually have a fairly diverse weather from a climatology, even on a day-to-day basis from a weather pattern. You know, sometimes the larger the area doesn't necessarily mean that it's certainly more difficult to observe. You know, it's a greater square mileage responsibility. But if the weather is not as diverse across that area, it's not quite as difficult as one would imagine. It's comparable to the workload that might be at an area with a smaller office, but it's the diversity of, and for us, the diversity of the customer base. No hurricanes.
True.
No water spouts here. You know, no boating interest, no cruise ships. You know, no shipping. You know, so you know, it's all this, and so somebody did this and mapped it out. 6 offices in the state of Florida. We're just one of 6. There's the one in the Keys, one in Miami, one in Tampa, one in Jacksonville, Tallahassee, and even out in the Pensacola area is covered by not a 7th Florida office. The office is actually just across the bay there in Mobile, but they cover parts of Alabama, of course. But it takes 7 WFOs to cover the state of Florida. It's almost like Texas. Well, who are we specifically? Well, we live in the community, we work in the community, and there's only about 23 of us, believe it or not. That's pretty small when you consider that we're talking about the administration, we're talking about the maintenance. There's only about 23 of us here that work in this office and cover that large area of responsibility. But we're here 24 hours a day, 7 days a week, 365 days a year. The office never closes. There is always, every hour of the day, there's always at least 2 people on the operations floor. That means New Year's Eve, Christmas morning, Thanksgiving dinner. There's always someone here. And why is that? You guys know?
Protect our lives.
Fulfill the mission, lives and property, and weather does not take a day off. Weather happens always, everywhere. And so there's always someone here. It's no mystery that we have 17 meteorologists here. That makes the core group of the people here. So we have degreed, trained meteorologists to understand, to know about weather, the science of weather. But we have a good knowledge base, but we also have a good experience base, which means we have quite a few folks who have been here since 1989 when the office opened. All gray beards, giving away who that might be. But we have a good, significant experience base. But when you talk about the weather forecast, you turn on the television, you turn on the radio, you go on the website, you know, so what's the weather today, tonight, tomorrow? You're going to go out today. You're going to go to the weather service office and do a tour. You might have wanted to know, is it raining outside? Do I need to take an umbrella? Do I need to grab a hat, a rain jacket, whatever? So we're pulling weather information all of the time. And the most typical way that we do that is just looking at the today, tonight, tomorrow forecast. Sun going to shine? What's the heat index today? You know, it's going to be windy. You know, those kinds of things. Very important stuff that hits you and I where we live, day in and day out. We do that out on the floor. But that's not all we do. Okay? That's not all we do. One of the things that we do, have an aviation forecaster that's working on the floor that is producing the forecast, the aviation forecast, which has sky cover, ceilings, cloud height, visibility, flight rules. Instrument flight rules, visual flight rules, marginal. Can you fly today? What's the weather at the departure site? What's the weather at the arrival site? Hey, it's going to take me 3 hours to get there. What's the weather going to be like when I get there? You know, those kinds of things. So at 10 airports in East Central Florida, Orlando International, most obvious, right? Planes are flying at Orlando International based on the terminal aerodrome forecast that's going out of the office. But there are also 9 other airports in East Central Florida that we produce these forecasts for. Daytona Beach, Melbourne, Vero, Sanford, Kissimmee, believe it or not, Leesburg, a lot of other places. Planes are flying. Trying to keep the boats a-sailing too. Remember we talked about 60 miles off the coast from Flagler Beach all the way down to Jupiter Inlet? There's a lot of pleasure boating that takes place here in Florida, right? That's the reason why some of us live here. But there's also a lot of commerce boating, a lot of charter boating that takes place here. A lot of it in the intercoastal waterways, some of it within 5 nautical miles of the coast. Sometimes, hey, you like to go fishing, you want to get out to the Gulf Stream, right? All of those areas we produce wind forecast, wave, sea state forecasts, swells, And also storms. Are there water spouts? Are there wind gusts that can flip these boats over? All of those things are forecast continuously out on the floor. You'll meet the marine forecaster this morning as well. And so here's just a quick glimpse of Port Canaveral. Anywhere from small boats to cruise lines are all users of our marine forecasts. Here's also another customer base that we have. It's the Department of Forestry. People don't necessarily realize that. So these guys and gals that are out here working the fire line, whether it happens to be what we call a wildfire, a fire that's out of control, or maybe once they get it under control, it's not because they wanted it to be there, or a prescribed burn, which means I'm going to burn this area off so it doesn't burn later in the spring or something. Well, ask these folks if a wind shift is not important to them. If there happens to be a house across the street, very important to those homeowners, very important to these crews that they don't get cut off. Right? Life and death stuff. Ah! Is this it? What does it mean cut off? It means I'm working the fire and I'm trying to keep this fire, you know, and next thing I know, there's another fire behind me. I have no way to run away. I've been cut off. I have nowhere to run. And when fire is occurring and I have nowhere to run, that's a bad thing. So weather affects how high flames can grow, the direction in which they will spread, the character of the flame. Will it create ambers and carry them, brands, if you will, and carry them away and start new fires? All of that's at play. But most of the time, you and I are just looking for what's the weather today, tonight, and tomorrow. I'm at the bus stop. Mom, are you going to make me wear that rain jacket? It's going to be cold in the morning. Oh, Billy's not wearing his coat. You know, all those things, right? Well, it's important. It's important. Now, what's really cool about this is that these days, probably if you've ever been on our website, you know, you just go, click on Melbourne, and this is all generated automatically. Nobody types this stuff anymore. It's all automatic. How in the world does that happen? Well, we don't type stuff up anymore. We produce forecasts of all those variables, if you will, every 2.5 kilometers, all across our area of responsibility. 2.5 kilometers, 2.5 kilometers, 2.5 kilometers. All big little boxes. So that wherever you click, this is automatically generated for you. And that's going to be the engine of the future. So if you're sitting there with your Droid, you know, whatever you got, and you want to change the thermostat on your house, but you're in Colorado and it's going to freeze in Florida, and you know, and you want to change all that, how do you know it's going to freeze in Florida? Because the forecast says so. Well, where am I at? I'm in Melbourne. How do you know? Because I clicked on it. And it pulls that information, and so you can see the revolution of things that are coming in the gridded weather era. This is the tip of the iceberg. But when it talks about life and property, we are talking about tornadoes here in Florida. Yes, Florida is one of the states that has the highest number of tornadoes on an annual occurrence. Sure, not killer tornadoes on an annual occurrence. I lived in Oklahoma for a while. I know what they look like. But I also walked the same tornado paths as the killer tornadoes in '98 and in '07 in Central Florida. 63 people in just those 2 nights died. Okay? Oklahoma statistics. But this is the warning that we put out more than any other severe thunderstorms. We have a lot of hurricanes in Florida, you know that. Tropical storms too, a weaker version of a hurricane. Together, you may hear us talk about tropical cyclones. That's just a faster way of saying, a clinical way of saying hurricanes and tropical storms that I haven't typed that out. Tropical cyclones is the category. Includes typhoons and so on and so on. Flash floods, river floods, fire danger, rip currents, even rip currents, and tsunamis these days. Because tsunamis are nothing more than waves that may propagate through our area of responsibility and splash up on our beaches, right? So we're not forecasting tsunamis, but we do have tsunami warning centers. But since we have the warning apparatus to get the word out, if we get information, we will also disseminate tsunami warnings. Now, the interesting thing about protecting life, property, economic interests in the environment is to identify all of the little hazards, all the hazards that can occur in the area, and we have, and then to consider every day whether or not the hazard's low, or maybe it's moderate, or maybe it's high. And so, kind of like, it's the old game. And you can kind of tell hazard by hazard, oh, big tornado day today. oh, little tornado day yesterday, you know, and then we can point out those hazards which are of greater concern to you. And just by visiting our website, you can do that, look at these and click on these and get maps for these, so you can tell, okay, you know, rip current, but surely not in Orlando, right? But you can, you know, give the geographic area and distribution of those hazards. And so, pretty important stuff, and done on a much more frequent basis these days. Threat assessment. What is the risk involved today, hazard by hazard by hazard, relative to the threat on your life? It is our job, our responsibility to issue warnings, which means we make the bells and the whistles and the go off, right? Well, that's done out on the floor. You'll see that. Scott will show you how we generate warnings, and you'll see the no weather radio aspect of it all. It's called emergency activation. Okay, it can be annoying sometimes. So why do I need to know about a special marine warning when I'm 20 miles inland? Well, there are ways that you can program your no weather radio so that you don't have that. Okay, and there's a booth out here today, and folks will show you how to do it. But if you turn on the television and somebody's saying there's a warning for this location, this county, from here to there, whatever, it comes from the National Weather Service offices. Period. The only one that have the authority to do so. I guess this is an authority thing. Otherwise, there'd be competition and there'd be chaos, right? No, get in the ditch. No, get out of the ditch. You don't want that. So only comes from one source, and we're the authoritative source for that. Since we're doing threat assessments all the time, if we see a hazardous condition evolving to the point where we think it's pretty likely that it might occur, we'll go ahead and issue what we call a watch. Severe thunderstorm watch. Severe thunderstorms are possible today. All right? We look for the conditions that might be fair. There's a lot of moisture. It's hot today, right? Ooh, the winds are howling, right? It's hot and the winds are howling. Probably get some thunderstorms. I bet they'll twist and spin too. Maybe a tornado day, right? Maybe it's cold aloft. Oh, hail, wait a minute, right? And so you start, and that's what they're thinking. You know? But if there's someone on the radar, our radar meteorologist, and they're looking at that storm, and they see signatures and say, there's large hail in there, there's a tornado in there, they'll issue the warning. And the warning means take cover now. It means we've done our best, you know, we either got a report of it, we got an observation of it, or we've done our best to analyze it on the radar, and we think it's there, and it's 3 in the morning, I guess I better hit the buzzer. and then the warning goes in. A severe thunderstorm, that's the warning that we issue more than anything else. It's for 58 mile-an-hour wind gusts, which is a bad day. I've seen them go up as high as 100. And quarter size hail is now considered severe. It used to be dime, but now it's quarter. And lightning, although we're Floridians and can kind of think this way, lightning is not a severe storm indicator. Only hail and winds. So you can have a storm which only produces 25 mile-an-hour wind gusts and pea-sized hail, but a ton of lightning. And so I like to report a severe storm. Well, how big is the hail? It's pea-sized. And the wind gusts, well, it blew a couple palm fronds around. But you should have seen the lightning. We're not going to be issuing a warning on it. But we are concerned. Why? Because lightning, on its own, is Florida's #1 killer. So it's not that we're not interested in it. We are very interested in it. It's just that we're not going to put out a severe thunderstorm warning. Just like if it didn't have a tornado in it, we're not going to put a tornado warning out on it. Right? So we've talked about tornadoes. Like it is in any state, more, I'll say, of the weaker variety occur than any other type. But we do get a fair percentage, a recognizable percentage, of what we call strong to violent tornadoes, killer tornadoes, like the ones that occurred in '98 and the ones that occurred in '07. Okay, and those are F2, EF2 through 5 tornadoes. Those are the strong and violent ones, and those are the ones we try not to miss. If we miss one of these, one of those land-falling water spouts, okay, it hurts the statistics, but you know what? A couple of beach umbrellas. But you don't want to miss those. The time of the year for killer tornadoes, usually in the spring, maximizing in February and March, but can occur at any time of the year.
So why?
Why?
Yeah, you think severe thunderstorms in summer, but yet they're
Yeah.
not tornadoes.
Now, notice that there is a minimum
Yeah.
here.
Yeah.
Now, if you looked at all tornadoes, not just killer tornadoes, you'd probably find this number up here in the summer. That's because there's water spouts and stuff like that a lot with it. But a few happen in here. But where this kind of swings up more often than not, it's tornadoes associated with rain bands and hurricanes. Yeah. That's the biggest contributor. But Florida's #1 killer is lightning. There is research that's taking place to try to figure out the best way to communicate lightning information, whether it be in watches and warnings or point-and-click functionality, an app on your phone, about when lightning is around or when the lightning threat is increasing. But the reason is because not only does Florida have more lightning deaths than any other state, but we have way more lightning deaths than any other state. That is our #1 killer. But you know what? When somebody dies from lightning, it's 1 here, 2 here, 3 there. Well, there was 10 this year, across the whole summer. But then the tornado happens, and boom, 42 people died in one night, or the hurricane occurs, and there was 28 people. And those are very high-profile events. They're on the national news. But the lightning takes them 1, 2 at a time, and it's just hard to get the profile up. You say, well, are you going to warn on every lightning bolt? And that's the challenge, right? So there's a lot of social aspects that are being pulled into that, but we're working on it. But the quick and simple message is, when thunder roars, go indoors. There's pamphlets out there. Please pick one up. And then finally, as we release you off to the rest of the office here, we wanted to make mention about NOAA Weather Radio. If you have one, great. If you need it programmed or having trouble programming yours, well, we have a booth today, so go ahead and stop by and find out how to do that. We do transmit out of Daytona, out of Orlando, out of Melbourne, and out of Fort Pierce, and you'll see the NOAA Weather Radio here in just a few moments out on the floor. And visit our website at weather.gov, and visit us on Facebook. And with that, I thank you very much.
Thank you. Thank you.
Does anybody else have any raffle tickets to turn in that you filled out? Any of the registration?
And then in this other workstation here, this is the hydrometeorological technician, that's Jackie. She is working to quality control all the data that is coming in, both automated as well as phone calls, people that are reporting heavy rain, flooding down on the Treasure Coast this morning. So she's determining the credibility of those reports. To her left, I want to show you, this is, I don't know if any of you have NOAA weather radios, but this computer system is what generates the broadcast. That weather radio broadcast generates from this office when we issue forecasts, coastal waters forecasts, zone forecasts, and the hourly weather roundups that play on the weather radio. Those text forecasts are processed by a synthesized computer voice that you will hear on the radio. If we issue warnings, you get the tone alert, followed by the severe thunderstorm or tornado warning. So we have 4 transmitters, Daytona Beach, Orlando, Melbourne, and Fort Pierce. Over here, this is the radar controller position. This is radar which is right out here, that golf ball. Underneath that golf ball is a big antenna, about 25 feet wide, and it's spinning through different elevation angles in the atmosphere. Right now it's at the top of this volume scan at 19.5, and when it's done with this one, it's going to drop back down to 0.5. It'll do some processing because it has completed the volume scan, now has dropped back down to 0.5. Start all over. So this takes about 5 minutes to do a full volume scan from 0.5 to 19.5. The radar transmits in the microwave at 10 centimeters. The Doppler radar does. The Weather Service Doppler radars are 10 centimeter wavelength radars, but the vast majority of the time, the radar is listening, it's not transmitting. It's listening for radar returns that are coming back. I'll come back to this workstation, and we'll talk about some weather that's going on. This morning, this is a rather long loop of the radar, and I've looped it pretty fast because it looks like there was a small-scale low-pressure meso-low that developed earlier this morning around St. Lucie County, Port St. Lucie area, and it dropped southward down through Martin County, and it produced some very heavy, excessive amounts of rainfall. We've had reports of 5 and even 7 inches of rain this morning in Jensen Beach area. And now since then, and you can see some of the advisories and warnings that Tony put out, flood warnings and urban flood advisories over the course of the morning, outlined here. Right now, I'll stop the loop, sit down so you can see that behind me. Right now we have an urban flood advisory that is in effect for Indian River, St. Lucie, and Martin counties. So he allowed the flood warning to expire because the intense heavy rainfall has decreased in intensity and coverage. However, he expanded it into Indian River County because now we seem to have another band that's setting up. And if you loop it again, it looks like that band is trying to lift northward. So we'll see if it's going to start making its way into southern Brevard County in the next couple of hours. And if so, that urban flood advisory will be extended northward. But we're not confident enough about that yet. So for Brevard County, there's nothing in effect at the moment. Well, one of the things, in addition to radar, there's also satellite imagery that we look at. This is visible satellite imagery. If I go back far enough, you can see it's kind of dark. See, there's no satellite because it's still night out. That's back at about 5 a.m. this morning. It's still dark. You can't see anything. And then once the sun comes up, that's when we're able to see the clouds and the visible. At nighttime, we look at the infrared satellite imagery, where we can see the clouds in the infrared. But during the day, we look at the visible. The satellite is a geostationary satellite. It's a NOAA satellite that's stationary at 23,000 miles above the Earth's surface. That just sits and watches the clouds over the northern hemisphere, specifically eastern North America. There's also another satellite that watches western North America. It's another GOES, geostationary satellite. Well, one of the things we also look at are weather models. This is the GFS model. This is a global model and one of the things starts with an initialization, a 0 hour from, this is the new forecast from this morning. And what we have here is, this is the old frontal boundary that came through a couple days ago that gave us that brief cold air outbreak Wednesday night, Thursday morning. Well, that boundary is now returning back to the north and bringing moisture back with it. And it appears that some of that moisture is going to stick around. High pressure to the north and low pressure to the south. We're going to get some breezy onshore winds, northeast to east winds over the next couple days. So it looks like it's going to remain pretty cloudy and with occasional showers over the next couple days. Then this high pressure system is going to be, this high pressure is going to be building southward, and it's going to push that moisture to the south and away from the area. And so we should dry out by, looks like Tuesday or Wednesday at the latest. Although that onshore flow is going to continue, so we can't rule out the threat for some isolated coastal showers, but the coverage and intensity of the showers should decrease. And then as we head later into the late next week, or late next week, another front going to try and make its way into the southeast U.S., but this high pressure system is going to keep it it's going to prevent it from coming into Florida. So no significant cold air is expected to come into Florida over the next 7 days. So it's going to remain mild, temperatures near or maybe even a little bit above normal for the next 7 days. At least that's the forecast. but I think it's been showing that, so we have some confidence in that. But that can change, you know, another model run can come in another 12 or 24 hours and show something completely different. And when different models say different things, that decreases our confidence in the forecast. Yeah.
Have you any broad generalizations, like is Florida getting enough or too much or not enough rain?
Well, I know our East Central Florida, I think depends on specifically where. In Melbourne, I think we're below normal in rainfall for the year. I think our average is about 50 inches a year. I can check that. Let's see, right now, okay, yeah. So since January 1st at Melbourne, we've had 41.84 inches. Normally we should have 50. So at this point, we're 8 inches below normal for the year in Melbourne. Now we can look at other sites as well, and they'll be somewhat different. Where are you from, Brevard County? Yeah, okay, so Melbourne would be. If there's anybody from Vero Beach, we can take a look at that. Now Vero Beach is in a different situation. Now they're not that far away, but yet they've had 60 inches of rain since January. Their normal is very similar to ours, which is about 50. But because they're at 60, they're close to 10 inches above normal, whereas we were 8 inches or so below normal. So that's one of the difficulties of forecasting in Florida, because you can have these, as we saw today, these locally heavy rainfall amounts. Very heavy rain, 5-7 inches in just a few hours, whereas just 50 miles away, they're not getting nearly that much rain, if any. So you can see these wildly varying totals over the course of a short period of time. Now, in addition to the GFS model, if we don't like what it is, if we don't like what it's saying, or we think we don't have a lot of confidence in it, there are other models we can look at. Another model that we have access to is a local model we run right here at this office. And you can see this is clearly not a global model, because the domain is simply Central Florida, or much of the Florida Peninsula. And so we can, this runs every 3 hours, and every hour it gives us a forecast.
Which one is that?
This is a wharf, a local wharf model.
WRI?
Yeah. Yeah, weather research and forecast model. And so this model is showing some, this is the precipitation is the graphic, so it's showing rain increasing across portions of Brevard County later this afternoon, with winds increasing out of the north. So that gives us another view of another model to look at. See what they're saying. And when the models say the same thing, that increases our confidence in the forecast. And when they say different things, then that lowers our confidence. And so when we write our forecast discussions, we will often discuss, discussions are background information for forecast to try and describe how we feel about the forecast. We have to decide, partly sunny, 30% chance of rain, but what do we really think? And we can't really say that in the forecast. So we do that in our discussion, which is widely read by the local media. And emergency management folks, and it's also available on our website for the public to view as well. Sometimes it can be a little technical, but we try to write in clear English at least, and not abbreviate too much. Well, I want to also show you how we make a forecast. This is our graphical forecast editor. And we actually draw the forecast first. And so this is the rain, these are pops or rain chances for today across Central Florida. And turn off and so we can also see what surrounding offices are saying. Jacksonville to our north, the Tampa office to our west, and Miami to the south. And so obviously we have some higher rain chances along the coast today, That's going to continue tomorrow. Maybe looks a little bit further north tomorrow. It looks like Brevard, northern Brevard Volusia may be the focus for heavy rain tomorrow. But still looks fairly overcast. Let's take a look at the sky forecast today. Yeah, 80%, and tomorrow 80%. So a lot more clouds than sun. So we go out 7 days with all of these grids and all these different parameters, wind and temperatures, min temperatures tonight, still pretty mild because of the cloud cover, highs tomorrow. There you go. Well into the 70s, despite the cloud cover. So when we're done with all of these grids, some marine forecasting and also some fire weather forecasting as well for the forestry folks if they're considering doing a prescribed or controlled burn. Once we're done with all of these grids, we run formatters. We can, this is our 10-county forecast area. And we can organize the different counties into groups if we choose, if the forecast is pretty similar. Typically, we separate Brevard County. Brevard County is so long, 72 miles long, and encompasses actually a few different climate zones between NIMS and NICO. So we'll typically separate northern Brevard from southern Brevard because temperatures at least, or maybe rain chances, can be quite different. We do something similar with Lake County. We've separated Lake County into northern Lake and southern Lake. Right now we've combined the two, but we can, if we wanted to, we could have southern Lake with Orange and Seminole if we wanted to. Also, Volusia, we have separated Volusia into coastal Volusia and interior Volusia, especially for those cold, behind the cold fronts, and sometimes interior Volusia can be a lot colder than coastal Volusia. So we have some, try to make a better forecast. We separate the counties into different zones. So when we're happy with that, we say we'll do a morning update, and we run it. And the formatter is changing. It's turning these pictures into words. And so we don't sit there and type today, partly sunny with a 30% chance of rain. The formatter does it for us because we spend most of our time with the graphics. So that's what it comes up with. Now we can still edit this if we don't like what some of the wording is. Isolated showers early in the afternoon and scattered afternoon showers. Well, we could say, becoming scattered. Becoming scattered afternoon showers, something like that. So we can edit it, and then when we're ready, we can transmit it. And then once it gets transmitted, it goes to the weather radio, and you can hear it on the weather radio. Anybody have any questions? Yeah.
Are there one or two major influences on Florida's weather?
Wow. Well, yeah, the sea breeze is a big influence. During the summertime, you get the sea breeze boundary that develops, and if you have enough heat and moisture, you can generate thunderstorms along the sea breeze boundary. And then you have the East Coast sea breeze and you have the West Coast sea breeze. And sometimes they collide, often they will collide, and they can produce additional thunderstorms. Yeah, so that's one of the big influences on our weather. In the summertime, we typically look to the east and to the south for tropical systems, summertime and maybe early fall, August, September. But then this time of year, we don't look so much to the south. Our weather really comes from the north and west as the cold fronts come in. So we're in the subtropics, so we have to look, different times of the year we look in different directions. Because our weather can come from pretty much any direction.
I was wondering how much work is actually done by the TV station weather guys. Do they just take your data and redo it, or do they apply their own models to it, or
well,
are they ex-weather people, or do they really know what they're doing, or?
A lot of them are meteorologists, and they certainly have access to our forecasts. And we have a chat directly with them, so if they have any questions or we have a comment about things that we're seeing on radar, we'll chat with them so that they know. Because we know that most people get their weather from television. They don't get it from us directly. And so it's in everyone's interest that we're all on the same page in trying to describe what's going on. So yeah, they have access to our stuff. It's up to them if they want to use it or not. Many of them, I mean, they do, I think, to some extent.
I know there's one station that has something called future track, like they can see in the future. They may calculate guesses, you know, but is that any different than you're actually doing?
They may have their own models. They may be running their own models. That's possible. I don't know. I do know what you're talking about. I think they all do have these future casts and radar. I don't know what it is that they're using. It isn't something that comes from us.
But probably not any more sophisticated than you're using either, though. Even though they're slapping a fancy name on it.
Yeah, well, yeah, that's what they do.
So you think they actually come up with their own models?
Well,
Are they not just
no,
using
they're not.
something like radar simulation from the RUC or something like that?
They're right. Yeah, I think they're not coming up with their own. They're using the NAM or the RUC or some other smaller scale.
That was a question I had about that.
But I don't know specifically what they use.
Yeah.
But they're not developing their own models.
I was going to say, I mean, there's no history behind their development.
Yeah. Now, a lot of them, I think every TV station has their own Doppler radar. I think that's true now. I think they all have their own radars. But they have access to ours, and they'll use ours as well. So we're all in this, together. It's a partnership. We're not in competition with them, and hopefully they don't feel that they're in competition with us. We're not on television or radio.
Do you have access to their feeds as well? I mean, if your system went down, could you use their radar to make predictions?
What we do is there are FAA radars. One is in Orlando, and there's another one near Palm Beach. And when our radar goes down for maintenance, for example, we'll use those Doppler radars for monitoring and even warning. I can show you an example of that. Let's see. Turn this on. This is the radar just south of Orlando International Airport. So the radar, that's the center, that's the radar point there. So it's able also to show our county warning area, and it's also showing. So sometimes we use this because it can actually, the radar here, there's actually like a cone of silence right at the radar, so we can actually see what's going on right at this location a little bit better from here because our radar can't look straight up. It only goes up to 19.5.
Can you just tilt on that? Is there different tilts?
Yes.
Okay.
There is.
Because I've noticed before, sometimes it's easier to tell what's going on. Depending on what the situation is, it's almost easier to tell what's going on here if I look at Tampa's radar. Every once in a while, just depends what you're looking for, I guess. Cloud tops, sometimes.
Right. Sure. Mm-hmm. Yeah, and we have access to Tampa's radar.
He actually wrote down a question. He wants to know what knots are. Knots. When you're talking about
the wind speed. Yeah, it's a measurement of wind. It's like miles per hour. It's a little bit different, but it's just another measurement of wind. It's used a lot by boaters. Boaters kind of think in knots, whereas landlubbers think of miles per hour.
I think what he's thinking too is the visual, a knot, like tying a knot. So he's trying to no. Oh, maybe I am.
That may be where that comes from. The term knot.
Yeah.
It's how fast, how many knots pass a certain point. That's like way back in the olden days. But that's it's a little bit different than miles per hour. But they're pretty similar. It's an explanation of wind speed.
What do you see? Thank you.
Sure. Any other questions?
I got one more about warning dissemination. Were you going to get into that? Anywhere else? I was just wondering, the question was, is like, say for a particular day, where a storm's producing a tornado, do you actually, or it looks like one is, no. Is there any backup mechanism to like that, like an automated alert that says this storm's conversation that cues you to look, to hone in on, like a sound or something like that, or flashing lights, sirens and all that?
Well, the radar will, if it detects a significant amount of rotation, we will get a red down alert, whether it's a mesocyclone or even TVS. Normally, though, we have someone that is dedicated to monitoring the radar. So oftentimes the cell will exhibit suspicious activity before then, and so we can issue. Here's our warn gen program. This is the warning program that we can issue special weather statements for wind or hail, excessive lightning.
So it's kind of like basically there's a tab at least you can pick, so you don't have someone that doesn't have to sit there and like type in all the words and all that kind of stuff.
No,
you got your zones and all that, and you just click and fill in the
right. Well, here I'll show you for example, we'll say for a severe thunderstorm warning, if we'll just pretend that we think this cell is severe. Do this one right here. So we'll just drag that there, and then we'll go back. That looks pretty good. We'll go back a couple frames and try and get a motion and a speed on it. So you see it drew this polygon, and we can adjust the thread area here that the computer automatically generates, but it usually does a good job. And you say, well, okay, we'll just kind of adjust it here. So this is the thread area. We can decide, meteorologist detected or the Doppler radar indicated, or if we're a little late, trained spotters have already reported. But normally we try and get the warning out before anything happens. Wind threat, whether it's wind or hail threat for a severe thunderstorm warning, and call to actions. What should people do? What is this cell? What are some of the danger signs? If it's producing some excessive or frequent lightning, we'll add that to the warning that this cell is producing excessive lightning in addition to hail and winds. If it's affecting a larger lake, like Blue Cypress Lake or intercoastal waters, we can talk about boaters and what they should be doing for this particular storm. So when we're done with that, and this takes less than a minute. I mean, once we decide to issue a warning, we need to move quickly, and then we create the text. And I can't show that here, but it would pop up on our workstation. We can edit it if we need to, and then we send it out, and that's when the weather radios go off, and the media, the cable, you hear the annoying tone. So once we hit send, then everybody gets it.
To a variety of outlets, say like the airport has a mechanism by which they receive a warning. Is it like a specific? I don't know. I mean, they just have a weather radio sitting there, or they have like something that comes
weather
on screen.
radios in the control towers. Yes, and we'll issue separate airport weather warnings as well for Orlando and Daytona. We issue weather warnings specifically for airports for hail and. Any other questions? One last thing I want to talk about is our ham radios that are right here in this cubicle. We have a ham radio. We have one HF, which would be a ham radio.
Radar. The actual tower itself is about 65 feet, and the radome itself, the wall on top, has an additional 35. So all in all, about 100 feet tall. The actual radar dish in the actual radar dome actually takes up, it goes all the way to the end of that space. So it's about 28 feet, I believe, in diameter. So while it's rotating, it's going almost towards the edge of that wall. If you were actually go inside there, there would hardly be any room for you to walk in front of it. You can only basically walk behind it. There are actually 155 WSR 88D Doppler radars across the country and other locations where we have offices, Hawaii, Alaska, and ours is actually the second oldest out of all of them. It was in operations beginning October of 1991, so it's been operating for 20 years now. Actually, we're going to be taking it down here for a couple weeks in January. We are going to be adding a new, it's kind of exciting for us because it's a new way of us looking at radar data. It's going to be called dual pole. Let Peggy get through. But dual pole is going to allow us to give us better precipitation estimates. It's also going to be able to allow us to discern between precipitation types. So we'll be able to discern between snowfall, we'll be able to determine between hail, and also with non-meteorological targets, whether it be ground clutter, bugs, birds that show up on the radar as well. So that's all going to be happening from January 3rd to the 16th. We're going to have the radar down. And I think Scott showed you some of the other radars across the area that we will be utilizing in case there's any type of rainfall, severe weather. So we do have coverage. So even though this one's down, we'll still be able to issue warnings and have that responsibility. Oh, another thing about the radar is it's I think 125 miles per hour is the amount of wind it can take. After that, then the potential is there for it to receive damage. And I believe Hurricane Andrew actually did take out the Miami radar. I think they received a gust right before the radar went down of up to 160 miles per hour.
Wow.
So 125 is the actual wind load for that tower. And I don't think there's anything else. Oh, did he tell you about the volume coverage patterns that the actual radar goes through? Yeah. Okay. Well, yeah, we have from the clear air mode, which does about 5 vertical scans, to precipitation mode, and that can go up to 14 vertical scans. Anywhere from ranging from 10 minutes with clear air mode all the way to about 4 minutes with our fastest precipitation mode. And even faster now, we have this new thing called AVSET, which I really won't go into, but we can get it down to almost 3 minutes as well. Maybe like 3 minutes, 3.5 minutes. So that's our Doppler radar. Any questions on that?
Straight line coverage, how far out does it go? 60?
That's a good question. I think it's usually like about, the way that our velocity products are set up, I believe over 100 nautical miles for some of our velocity products. Precipitation is longer than that, but reliability when it comes to rainfall estimates is again, or not, it has to be more than 100 miles. I can't remember the exact number, but it basically covers. The reason why they're placed strategically around the U.S. is so that it can cover the actual county warning area, and that's why we go all the way up to Volusia, all the way down to Martin County, and west into Orange, Osceola, Okeechobee, and Lake. So we get reliable data from this radar all the way out to those distances. And now I'll show you down here to these 3 pieces of equipment. Okay, these 3 pieces of equipment are basically all doing the exact same thing. They're measuring rainfall, but just in different ways. This is the Fisher-Porter rain gauge. Basically what it does is it collects, the rainfall goes into the instrument, and then it actually weighs the rainfall, and then it takes the weight of it and converts it to a measurement. And this data is downloaded once a month by us, and we send it into the National Climatic Data Center. So we don't usually use this in real time. It's just another way of us to get rainfall data. And then this is our manual rainfall gauge. This is something that we do come out and take manual rainfall observations every 6 hours. And inside of it is this tube. So this funnel is going inside this tube. And basically the amount of rainfall that if it reached the top would be about 2 inches. And we take a measuring stick and every 6 hours we just drop it in there. It'll show like a little bit of a wet line of where the rainfall ended, and then we'll just use that measurement. And now, if we were to have more than 2 inches of rainfall within a 6-hour period, then the water would overflow into this bigger bucket, and I believe it would hold up to 8 inches. Now, if we get more than that in 6 hours, we probably have to come out here and keep an eye on it. But so that's our manual rainfall observing equipment. And this is going into that instrument panel that I showed you before we walked outside. This is our tipping rainfall gauge, tipping bucket. And inside there's an actual little device. When the rainfall goes in, every 1/100th of an inch, it'll actually flip and tip. And that will set off the, you'll hear like